Today's lesson is extension 13.2, factoring expressions, on page 566. Our purpose today is to factor an expression so you can apply this skill to real-world situations. Now, we've had lots of experience with factoring expressions. The difference between what we've done in the past and what we're going to do today is today we are going to be using integers as well as rational numbers. So when factoring an expression, you write the expression as a product of two factors. You can use the distributive property to factor expressions. Now, typically, the first step that we take is that we find the GCF of the two numbers and factor it out. So I have the expression 30x plus 12. I would make a t-chart to find the GCF of these two numbers. And if I completed that, I would know that the answer is 6. The next step is to take that 6, and we're actually going to put it in front of a set of parentheses and then divide to find out what's left. So 30x divided by 6 leaves me with 5x. 12 divided by 6 is 2. So my factored expression is 6 parentheses 5x plus 2. The way to check and see if this is right is simply to multiply. 6 times 5x is 30x. 6 times 2 is 12. And I put the addition symbol back in between it, and I'm back to where I started from. These are the types of problems you've done before. The only difference today is, as I said, it will be integers and rational numbers. So, factoring out the GCF, I have the problem in example 1, 24x minus 18. We want to find the GCF. So the first thing, of course, that we do is make a factor, list the factor pairs in a t-chart. Then I'm going to identify the numbers that are the same. So I have 1, 2, 3, and 6. Now, of these common factors, 6 is the GCF, so it is going to go in front of the set of parentheses, and what's left when I divide is 24x divided by 6 is 4x, 18 divided by 6 is 3. So when I factor it out, I get 6 parentheses 4x minus 3. Once again, this example is actually just like what we've done in the past. New content. So you can also use the distributive property to factor out any rational number from an expression. So in example 2, it says factor 1/2 out of 1/2 x plus 3/2. So we're going to write each term as a product of 1/2 and another factor. So basically, what times 1/2 gets me those numbers that I started with? Well, to get 1/2 x, all that I do is 1/2 times x. For 3/2, if I were to factor 1/2 out, I would have 1/2 times 3. Because if I put my 3 over a 1 and multiplied, I would be back to my original number of 3/2. Okay, so we have factored 1/2 out because I know 1/2 times x plus 1/2 times 3 gets me back to my original problem. So I put the half in front of a set of parentheses, and I'm left with x plus 3 in the parentheses. So that is my final answer for this problem. One more example. On this one, we are going to not have a rational number, but instead work with negatives and integers. So it says factor -2 out of -4p plus 10. So once again, I need to think about what times -2 will get me back to the original problem. So if -4p, if I take out a -2, I need to multiply -2 times 2p to get 4p. If I take 10 and divide it by -2, I know that I need to I would get -5 because negative 5 times negative 2 gets me back to 10. So now I've got my negative 2 factored out. And when I rewrite the other part of the problem in parentheses, I'm going to have negative 2 parentheses 2p plus a negative 5. When I simplify that, I get negative 2 parentheses 2p minus 5 because I'm going to get rid of the addition sign and just keep the negative sign. So, final answer. Now, when you simplify problems, when it's in its simplest form, we're not going to keep an addition and a subtraction or a positive and a negative sign right in front of each other. The simplified version would only have one sign between each number. Now, you know that adding the opposite is what you do when you have a subtraction. So to get rid of that sign, if I'm adding negative 5, that is the exact same thing as just subtracting 5. That's why I'm able to get rid of the extra symbol.